Today in DC electrical circuits, we're going to be taking a look at lab number 2, DC sources and metering. The objective of this exercise is to become familiar with the operation and usage of basic DC electrical laboratory devices, namely DC power supplies and digital multimeters. Now I've given you a reference section here, and it's from Sham's Outlines Basic Electricity 2nd edition, and we should take a look at Chapter 2, Electrical Standards and Conventions. Now if you haven't already done so, I recommend you read Chapter 1, all about the nature of electricity, where it talks about the structure of the atom and the idea of these electrons. It also covers the electric charge and the potential difference, which is basically what we're going to be measuring today with volts. They talk about the differences of direct and alternating currents and voltages. We're just going to be working with DC voltages. So Chapter 2 is all about electrical standards and conventions, and they talk about units, and we want to know all about volts. We need to know about the graphical symbols used in electrical diagrams. So when we see a diagram like this, we can equate it to pieces of equipment that look like that. And last week we talked about metric prefixes, and this week we're going to be using them. We're going to be using the milli because we measure millivolts. I don't think we're going to get up to kilovolts. That would be quite dangerous. But we will be using standard volts, and it may go down to millivolts. So on my bench here, I have the digital multimeter, and it has a few ranges on it. This side is for current ranges, so this makes it an ammeter. We have the AC voltmeter, the DC voltmeter, the ohms reading for resistance, the diode checker, and the capacitance checker, and over here we have a frequency checker. We have the common terminal, and we have the volt, ohm, capacitor, and hertz inputs over this side. On this side we have the milliamp input and the amp input for higher currents. Down here we have the triple DC power supply. It has an output from 0 to 6 volts, 0 to 20 volts, and 0 to minus 20 volts. It has a common terminal, so all these output voltages have to return to the common. This is the ground terminal, and it connects the casing of the power supply to the ground on your AC plug. The theory and overview talks about the importance of the power supply and the digital multimeter. Talks about accuracy, precision, and resolution, and the typical accuracy specification. Now on your lab, I've given you a picture of the Agilent power supply that we're going to be using and the Mastec digital multimeter that we're going to be using. I've gone and got the specification for the digital multimeter to show you the resolution at each range as well as the accuracy. So for the 400 millivolt range, you can see it's 0.3% plus 5 digits, and on the 4 volt, 40 volt, and 400 volt range, it's 0.3% and 2 digits. I've also gone out and found the specification on the power supply meter, and you can see its accuracy is 0.5% of the output and 2 counts. Now I want you to notice this caution. The power supply does have overload protection, so whenever the yellow lights come on, this is for caution, and you should turn off your power supply immediately. So this is the Agilent power supply, and this is the button to turn it on. And these are the meter buttons. So right now I have the plus 6 volt button pressed in. So it's telling me what's coming out of the plus 6 volt terminal. So this is the knob to adjust the voltage. So this is the plus 6 volt adjustment knob, and as I rotate it counterclockwise, you can see the amount of voltage that comes out is being reduced. These are your overload lights, and if you were to do something silly like plug a banana lead into the plus 6 volt terminal and then plug it into the common terminal, you'll see that the overload light comes on and the voltage drops to nearly 0. So in procedure number 1, what we're going to be doing is computing the inaccuracy caused by the scale and count factors. So we're going to do this for the full scale reading, and we're going to record these values in table 2.1. So on the 400 millivolt range, 0.3% of 400 millivolts is 1.2 millivolts. To do that calculation on your calculator, you type in 400 to the exponent minus 3. That would be 400 millivolts times 0.003. That will give you 1.2 millivolts. So as you can see, we've done the 0.3%. Now we have to go plus 5 digits. And each digit is 0.1 millivolts. So the calculation is 5 times 0.1 millivolt. To enter it on your calculator, you type in 5 times 0.1 to the exponent minus 3. So the answer is 0.5 millivolts. So adding the 1.2 millivolts to the 0.5 millivolts, we end up with 1.7 millivolts total. Remember, when you're doing the other ranges, it's plus 2 digits, or plus 2 counts. It's only the 400 millivolt range that is plus 5 counts. So moving on to step 2 of the procedure, what we want to do is we want to get 2.2 volts out of the plus 6 volt supply terminal. So I'll show you how to do that now. So following step 2 on the procedure, on the power supply, we're going to press the plus 6 volt button underneath meter. Now we're going to have to turn on the power supply, and it says to set the adjustable power supply to 2.2 volts via its display. So this is its display, and we're going to be using the plus 6 volt adjustment knob, and we want to get as close to 2.2 volts as possible. So there we go, 2.2 volts. We're going to record this display voltage in the first column of table 2.2. So in table 2.2, I record my reading of 2.2 volts. So now the next thing I want to do is turn on the digital multimeter till I get to the DC voltage setting. So the DC voltage setting is the second stop over. It's got a V with a flat line beside it. So turn the knob 1, 2 clicks over. So the next thing I need to do is connect the power supply to the voltmeter. I do that by connecting a banana lead from the black terminal to the common on the digital multimeter, and then connect a red lead from the plus 6 terminal to the red volts in terminal on the digital multimeter. Now, because our meter is auto-ranging, it automatically puts the most precise number down for us. If you can't see your display, the yellow button will turn on the backlighting. So now you can see it's got a slight green glow to it. Now what the lab asks you to do is put it on manual range, and they want you to use the 40 volt full scale range. So if you press the range button, it will take you out of automatic range. Now you can see in the top corner here, it does say auto right now. So when I press the range button, the auto is missing out of the top corner. If I press range again, it puts it in the 40 volt range. So you can see there's a digit, digit, decimal point, digit, digit. So we're reading 2.2 volts, and they want us to record that in table 2.2. So on table 2.2, I record 2.20 volts under the 40 volt scale. Now they want you to change the range to the 400 volt scale. So we're going to press the range button again, and now you can see it's digit, 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 decimal point, digit. So this is the 400 volt scale, and our reading is 2.1. So in table 2.2, I record 2.1 volts under the 400 volt scale. Now, on the final step of procedure 2, what they want you to do is to now adjust the power supply for 5 volts and repeat your readings for the last row of table 2.2. So in table 2.2, write down what you set your power supply to, what your reading was on the DMM for the 40 volt scale, and what your reading was on the DMM at the 400 volt scale. Now in part 3 of the procedure, we're going to change the power supply meter to the plus 20 volt button under the meter. And we're going to adjust our supply for 9.65 volts. So, on the Agilent Power supply, we're going to press in the plus 20 volt button. Now this is the voltage coming out of the plus 20 volt terminal. Over here we have the voltage adjust, and if you adjust it all the way up, as mine is, you can see I can put out a maximum of 22.8 volts, and if I turn it counterclockwise, you can see I can turn it all the way down to 0 volts. They want you to set this to 9.65 volts. Once you have it at 9.65 volts, we need to connect the digital multimeter's positive lead to the plus 20 volt terminal. So in table 2.3, I record the power supply meter reading, and it's 9.65. Now you can see the digital multimeter has automatically selected the 40 volt range. It is on auto. It's automatically selected the 40 volt range for you. So when you press the manual range button, it will stay on the 40 volt range. So in table 2.3, I record the meter reading on the 40 volt scale is 9.66 volts. I'm now going to select the 400 volt range by pressing the manual range button, and the reading is 9.6 volts. So on table 2.3, I record 9.6 volts. Now in the last part of step 3 of the procedure, they want you to adjust the power supply to 15 volts and repeat your reading for the last row of table 2.3. So on table 2.3, adjust your power supply voltage to 15 volts. Record the power supply meter reading, the digital multimeter meter reading on the 40 volt scale, and the digital multimeter reading on the 400 volt scale. On procedure 4, we're now going to be looking at the minus 20 volt terminal. So, on part 4 of the procedure, we're going to press in the minus 20 volt button under meter. And you'll notice we're getting a negative reading already. Do not move your plus 20 volt adjustment knob. We're going to be adjusting the negative voltage with the tracking ratio knob. Right now it is in the fixed or detent position. When you rotate it counterclockwise, it should click. It's now out of the fixed position, and you'll notice as I rotate it counterclockwise, the voltage magnitude becomes less. So I can adjust it all the way down to 0 volts and actually increase the magnitude to minus 15 volts. Minus 15 is the maximum because that's what we have the positive terminal set to. So the tracking ratio tracks the minus 20 to whatever's set on the 20 volt terminal. So for our first reading, we want to set the meter to minus 5 volts. Notice the minus sign. So when you do have minus 5, record that in table 2.4. So in table 2.4, I record my reading as minus 5.00 volts. Now we need to move the red lead from the plus 20 volt terminal and put it in the minus 20 volt terminal. Now when the digital multimeter is in auto range, it's automatically going to select the 40 volt range for you, but please make note of the minus sign in front of the 05.00 volts. Record this in table 2.4. So in table 2.4, I record my result as minus 5.00 volts. Changing my range to the 400 volt scale, you can see the answer is minus 4.9 volts. So in table 2.4, record your answer, and don't forget to put the minus sign in front of the number. It's minus 4.9 volts. Now in the last part of procedure 4, they want you to adjust the power supply to minus 15 volts. Since the plus 20 volt terminal is already set to 15 volts, if we move the tracking ratio to the fixed position, and you heard it click, it will automatically give you the minus 15 volts on the minus 20 volt terminal. So in table 2.4, record your reading from the meter from the Agilent Power supply, and then from the digital multimeter on the 40 volt scale, and then from the digital multimeter on the 400 volt scale. So for step 5 under procedure, they want you to change the red and black leads on the digital multimeter. So in step 5 of the procedure, what they're saying is they want you to reverse the leads going to the digital multimeter. Notice the digital multimeter is reading minus 15.02 volts. When I pull out the red lead and the black lead and put the black lead in where the red lead should go and the red lead in where the black lead should go, you'll notice my reading is plus 15.02 volts. So the voltmeter is sensing the minus 15 volts incorrectly because we've put the leads in backwards. We're going to cover voltage sensing in more detail in the future labs. So in step 6 of the procedure, we're just going to be checking our meter to make sure that we haven't moved any of our voltage adjustment knobs. So in step 6 of the procedure, they want us to check the meter on the power supply to make sure that we haven't inadvertently changed any of these voltage adjustment knobs. So they're saying on the plus 6 volt, we should be getting 5 volts. On the plus 20 volt meter, we should be getting our 15 volts. And on the minus 20 volt meter, we should be getting our minus 15 volts. All of these voltages are available at the same time on these 3 different outputs. Once you've entered the data in the tables, you can now answer the questions. Now, as I mentioned last week, it's very important that you get your instructor to initial your lab to indicate that it's complete during your assigned lab time.